Hello and welcome to GM Service Know-How. I'm Linda Quiros. In this program, we're going to take a look at several engine performance issues that will help you maintain your customers' vehicles in peak condition. More specifically, we'll examine some new procedures for cleaning fuel injectors on both 3100 and 3400 V6 cars and central sequential fuel injection trucks. We'll also demonstrate misfire diagnostic procedures using a 3800 engine. In this portion, we'll examine the DTCs involved and possible causes of misfire using strategy-based diagnostics. Then we'll move on to evaporative emission system diagnostics, which are critical to OBD2. For Cadillac technicians, we'll try to clear up some of the confusion about the LEARN procedure used when replacing Catera ECM or Immobilizer. And we'll finish with a look at a new rod bearing measurement tool. We've added subtitles between sections to help you scan up to and view specific portions of this tape at a later date. And don't forget to thoroughly read the booklet that accompanies this tape. It contains everything we're going to talk about today, plus additional information found only in the booklet. The booklet also contains the test that you'll need to take to get your training certificate. Instructions for taking the test using the GM website are at the end of this video. We've got a lot of information to cover, so let's get right to it. Clogged fuel injectors can cause a host of drivability concerns, ranging from rough idle to misfire. If you determined after performing a strategy-based diagnostic procedure that one or more fuel injectors are clogged, you may be able to clean them rather than replace them. Many technicians are using aftermarket cleaners and techniques versus recommended GM cleaner and procedures because the previous procedure was not adequately cleaning the injectors. However, research shows that the aftermarket cleaners can be too strong and possibly damage the elastomers used for injector seals. This could create deposits inside the injectors and cause future drivability concerns. But there is good news. GM Top Engine Cleaner is now used at a solution of 10% on 3100 and 3400 V6 passenger car applications only. This increased mixture delivers the required cleaning performance, but is still safe for elastomer seals. You should know that GM Top Engine Cleaner is the only injector cleaner that is approved for use with GM fuel systems. You're about to see the fuel injector cleaning procedure as demonstrated on a 1999 Malibu with a 3100 V6 engine. Keep in mind that fuel injection system pressures are varied depending on the type and model year of the system. Specific procedures are necessary for effective cleaning, so always refer to the appropriate service information for the specific vehicle you're working on.
The first step of the fuel injector cleaning procedure for our specific multi-port system is to disconnect the 10-pin fuel rail electrical connector. Then connect the injector coil balance tester with the proper test harness adapter for V6 passenger car applications at the rail side of the connector. This will allow the upper intake components to remain installed. Do not use the injector balance test on the scan tool for this procedure. Perform the balance test and record the fuel pressure drop at each injector. Use the table in the service information to ensure that cleaning is an appropriate fix. If the difference is less than 3 psi, cleaning is not the answer and further diagnosis is necessary. After removing the adapter and test harness and reconnecting the rail 10-pin connector, make sure the vehicle has at least a quarter tank of fuel. Pour 48 milliliters of GM Top Engine Cleaner into the injector cleaning tank and fill the remaining portion of the tank with the recommended gasoline for the vehicle being serviced. Then put the top back on the tank. Remember to thoroughly review and heed the instructions that are supplied with the tool. Next, remove the fuel pump relay to disable the pump and disconnect the oil pressure switch connector if the vehicle is so equipped. After connecting the J35800-A cleaning tank tool to the fuel rail supply, pressurize the tool to 25 psi with shop air. Be absolutely sure that you do not exceed 25 psi. Doing so would allow the cleaner to bypass the regulator and enter the vehicle's fuel tank, which can damage the fuel pump. Then remove the vacuum line at the fuel pressure regulator and plug the vacuum hose. Start the engine and let it idle until the vehicle runs out of gas. Once the engine runs out of gas, shut it off and remove the shop air supply. Also disconnect the J35800-A tank from the vehicle. Then reconnect the fuel pump relay, oil pressure switch connector if equipped, and the regulator vacuum hose. Restart the engine and let it idle for 2 minutes to make sure the top engine cleaner is completely flushed from the rail and lines. Then repeat the injector balance test at each injector. If the fuel pressure drop differences are 2 psi or less, the cleaning has been effective. If differences remain above 2 psi, replace the injector with the lowest fuel pressure drop according to the procedures in the service information. Finally, clear any DTCs and road test the vehicle to confirm that the customer concern has been corrected, and advise the customer that changing fuel brands may help prevent this condition from happening again.
Now that we've seen the injector cleaning procedure for multi-port fuel systems on 3100 and 3400 V6 passenger cars, let's turn to trucks. With the central sequential fuel injection system, a deposit buildup on the poppet valve ball and/or the seat can cause the poppet ball to stick in the open or closed position, resulting in a misfire or other drivability condition. This condition may cause rough engine idle after startup, especially if the vehicle sits for several hours before the vehicle is started. The service engine soon light may also illuminate. After using strategy-based diagnostics to verify the concern, your first thought may be to replace the dirty poppet valves with new ones. But don't head over to the parts department yet. Replacement may not be the proper repair for this concern. You're about to see instead a new cleaning procedure that has been proven to be effective in restoring poppet valves to a like-new condition. There are 2 steps to this procedure. First, you'll need to make sure the poppets are operational. Then you'll run the engine on a solution of 5% GM top engine cleaner and 95% gasoline. Remember, the 10% spec we talked about earlier only applies to 3100 and 3400 V6 passenger cars. Now, let's go through the entire procedure step by step on a CK. Note that the fuel system hookup differs slightly on ML and G vans, as well as the P chassis.
The first step in the fuel injector cleaning process for CSFI fuel systems is to make sure the poppets are operating. This is important because the procedure will not work on poppet nozzles that are stuck in the closed position. Begin by removing the fuel filler cap to relieve vapor pressure from the fuel tank. Then remove the PCV clean air tube and set it aside. To gain access to the fuel line connections, remove the bonnet and the inlet tube at the throttle body. Also, remove the brake booster vacuum hose and the connector from the intake manifold. Then remove the electrical connector at the fuel metering body as well as the ignition wires on the driver's side of the engine. Next, remove the fuel line bolt at the rear of the manifold. At this point, you'll need to relieve any fuel pressure at the service port according to service information procedures. Be sure to use a shop towel to catch any fuel that may exit the service fitting. With the nuts and clamp removed from the fuel pipe, carefully remove the pipes from the metering body. It may be necessary to remove the clamp on the bell housing if equipped. Be sure not to disturb the O-rings, washers, or spacers in the metering body. Next, install the metering body jumper block with the proper screws. Make sure the O-rings, washers, and spacers remain properly positioned when you install the jumper block. On this CK, as well as an ST, install the IAFM fuel transfer tube recycling block to the fuel pipes. Be sure to use the system clamp with the J44466-13 screws. Then locate the EVAP Diagnostics station. Close the valve on the tank and remove the regulator. Then install the CSFI special tool regulator and hose assembly to the tank. The regulator is preset to 150 psi. Next, connect the hose to the jumper block tool that you previously installed on the manifold. At the fuel metering body harness connector, you'll need to install the injector coil balance tester using the 210 tester adapter box and the appropriate adapter for the application being serviced. With the injector coil balance tester installed, set the tester amperage selector to 0.5 amps. Then open the valve on the EVAP station tank to pressurize the fuel system. Read the pressure gauge to be sure you have 150 psi. If the reading is low, the EVAP station tank may need refilling. Once you know you have 150 psi, close the valve. Use the injector coil balance tester to energize each injector. Look for a pressure drop at the gauge to ensure each injector and poppet nozzle operates properly. Be sure to repressurize the system after each injector is triggered. A stuck injector and poppet nozzle will not show any pressure drop. If you find an injector assembly that appears to stick, repeat the procedure several times until you're sure that it is either operational or needs to be serviced. When you've finished, remove the regulator hose assembly from the jumper block. Once you've shut off the pressure from the tank and bled off the pressure at the regulator, remove the injector tester at the metering body. Now you're ready to reconnect the metering body electrical harness and the engine components you removed earlier. Next, locate the J35800-A fuel injection cleaning tank. With the bottom valve closed, add 24 milliliters of top engine cleaner to the tank and fill the remainder with the correct grade gasoline for the vehicle being serviced. Then install the top. Note that this is only a 5% solution, half of the 10% solution used in the 3100 and 3400 V6 passenger car example. As always, it's important to thoroughly review and heed the instructions that are supplied with the tool. With the cleaner tank suspended, connect its hose to the service port on the jumper block. Then open the valve at the bottom of the tank. Using shop air, pressurize the cleaning tank to 75 psi. Note that this is significantly higher than the 25 psi used in the passenger example. This is required to open the system's poppet nozzles. Then start the engine. You may need to readjust the pressure in the tank after the engine is started. Let the engine idle until it stalls because the fuel supply at the cleaning tank is empty. Turn the ignition off and remove the air supply at the cleaning tank. Depressurize the tank tool, remove the service tools, and reconnect the vehicle's fuel lines. You'll need to remove the same engine components for access as you did earlier. Once the fuel lines are reconnected and all components reinstalled, add 1 ounce of port fuel injection cleaner, part number 1234-5104, at the filler for each gallon of gasoline estimated to be in the tank. Have the customer add the remaining cleaner to the tank at the next fill-up. Then restart the engine and check for any fuel leaks. Finally, using a scan tool, check for DTCs to confirm that the customer concern has been corrected. And be sure to advise your customer that changing their brand of fuel may prevent the condition from reoccurring.
Again, let me emphasize that for 3100 and 3400 V6 passenger cars, GM Top Engine Cleaner is now used at 10%, which delivers the required cleaning performance. This solution is safe for the elastomer seals and helps to avoid creating deposits that can hamper injector performance. Trucks continue to use a 5% solution. GM Top Engine Cleaner is available in pre-measured 24 milliliter containers to make measuring easier. Use 2 containers for 3100 and 3400 V6 engines and 1 container for CSFI engines. Also, be aware that fuel injection system pressures are varied depending on the type and model year of the system. Some systems have specific procedures that are necessary for effective cleaning, so be sure to consult the available service information before performing this procedure. Now, let's move on to the engine misfire conditions. The crankshaft position, or CKP sensor, reads the crankshaft reluctor for fuel and ignition timing. Any significant changes in crankshaft speed are also used to identify misfire. That's because the engine speed slows if combustion does not occur. If even 2% of all cylinder firing events are misfires, emission levels may exceed mandated standards and cause the MIL to illuminate. Under severe misfire conditions, damage to the catalyst could occur. In this case, the PCM will cause the MIL to flash as long as the misfire remains at catalyst damaging levels. DTC P0300 identifies system misfire. DTCs P0301 through P0308 are used for individual cylinder misfire, depending on model. Realize that misfire in one cylinder can also cause misfire at nearby cylinders. Diagnosing a coded or non-coded misfire customer concern requires complete use of strategy-based diagnostics. Statistics show that failure to fully investigate the concern or skipping steps in the diagnostic procedure dramatically increases the rate of comebacks. Looking at the ignition system, the module and plugs can affect misfire as well as the crankshaft position sensor and reluctor. But it's important to understand all the possible sources of misfire beyond the ignition system. Mechanical conditions related to the engine rotating assembly can cause one or more cylinders to have low compression. Severe misfire conditions can be caused by soft camshafts with worn lobes, damaged pistons, piston rings, or cylinders. The same is true for burned, stuck, or bent valves. Leaks in the air induction system may cause the engine to go lean, which can cause misfire. Sometimes this may be nothing more than a dirty air filter. Low fuel pressure can also cause a lean condition. Malfunctioning fuel injectors is another cause of misfire. This may be due to contaminated fuel, which can gum up the injectors. Contaminated fuel can also provide unreliable combustion that can cause misfire. Other causes of misfire can be a malfunctioning EGR system, extended idle, repeated short trip operation, or low fuel level operation. Because of the many possible causes of this condition, it is vital that you understand the strategy-based diagnostic procedure for misfire. Let's review the diagnostic strategy for engine misfire on a Buick Park Avenue with a 3800 engine.
To begin misfire diagnosis, verify the concern by checking to see that the MIL is on. A flashing MIL identifies stronger misfire at levels that may damage the catalyst. Check for a DTC P0420 trouble code. Other signs to look for are engine hesitation or stumble and poor fuel economy. Once you've verified the concern, inspect the spark plug wires, making sure that none are loose or damaged. Also be aware that electromagnetic interference, or EMI, from the ignition coils can affect the crankcase position sensor signals. Therefore, make sure the CKP harness is more than 2 inches away from the ignition coils. And while you're at it, make sure all injector connections are tight. Next, perform a powertrain onboard diagnostic system check and look for any other DTCs that could influence misfire. Also, check to see if there are any bulletins that may offer direct answers to symptomatic concerns as well as overall system-based concerns.
The vehicle's individual service history may show related repairs or repairs of other components in the area that may affect the CKP signals. For example, maybe the harness was rerouted during a repair that now induces EMI on the CKP circuit. If the harness cannot be rerouted for some reason, special insulated tape is available to wrap the harness.
Another possible cause of misfire is high resistance in the secondary wiring. Perhaps repairs were made to the engine or engine management system without the necessary CKP system variation learn procedure. Or maybe it was performed but was not successful. This learn procedure can require several attempts before it succeeds. Next, you'll need to determine if the misfire condition is random or cylinder specific. Do this with a scan tool while the engine is running. The scan tool can identify misfire with counters and a bar graph. When directed by the procedure, use the secondary ignition diagnosis procedure to verify proper ignition system operation. You'll need an ST-125 spark tester. Depending on engine application, you may also need spark plug jumper wires. Follow the procedure listed in the available service information. This test is important because today's higher compression ratios and more aggressive timing curves require a much more accurate spark. Contamination and air gaps between the plug electrode and boot can cause carbon tracking and therefore misfire. Carbon tracking is evidenced by dark lines on the plug ceramic that cannot be wiped off. If carbon tracking is shown, replace both the plug and the wire. Carbon tracking will probably reoccur if you change just one or the other. In addition to carbon tracking, inspect each spark plug for the following conditions: a loose post or a broken insulator around the center electrode. Make sure the plug has the correct gap and that the platinum pad isn't missing. And also make sure the connection isn't loose between the spark plug wire and the plug itself. CKP signal integrity can be checked with an oscilloscope. You'll need to jumper the circuit at the ignition module to interface the signal lead. The negative lead is connected to an engine ground. The signals will differ according to the type of CKP system being tested. For example, this 3800 engine uses a Hall effect system. This screen shows proper 3X signal operation. The PCM uses the 3X signal from the reluctor as a base for ignition control. Since the 3X signal has a varying duty cycle, it would be hard to diagnose with a DVOM. The scope may show a non-sync or random pattern from the crankshaft position sensor, which can confirm a sensor condition. Continue your diagnosis using the emission hose routing diagram to verify proper vacuum hose routing. Then inspect the PCV valve. Make sure it is properly installed with good O-rings if equipped. Next, inspect the air inlet system through the throttle body for damage or foreign objects that may affect the operation of the mass airflow sensor. Then verify that you have proper fuel pressure. Remember to check the service information for the specific vehicle pressure specification. They are different for each model. Refer to the fuel system pressure test in the service information. The accompanying booklet for this service know-how release has a comprehensive chart for your reference. With the fuel pressure verified, inspect the grounds as well as power for the PCM and the ignition control module. Next, visually and physically check for vacuum leaks at the intake manifold, EGR adapter, valve and feed pipes, and the injector O-rings. You can verify that the EGR pintle is allowing proper flow with a scan tool. If in doubt, remove the EGR valve and verify that the pintle isn't sticking and there is no carbon buildup at the pintle and the seat. Continue your misfire diagnosis by checking the injectors using the fuel injector balance test and the J39021 injector coil balance tester with the appropriate test adapter. We demonstrated this in the previous segment. There are a number of mechanical conditions that could affect engine rotational speed and cause misfire. This could range from basic engine mechanical problems with the pistons, valves, or accessory components and/or mountings, as well as loose or broken engine mounts. Misfire can even be caused by a damaged accessory belt or an overfilled oil condition. Performing a running compression check can help you identify any internal mechanical problems. Be sure to release the gauge pressure after you start the engine or you won't get an accurate reading. Also keep in mind that vacuum testing can be used to identify engine mechanical problems. However, it is best that the vehicle run at 2,000 RPM for the readings to be accurate. Finally, check for a transmission TCC problem, such as chuggle or shudder, by performing a road test with the scan tool. The final step in strategy-based diagnostics is to verify the repair. To do this, review the freeze frame data in the scan tool. After clearing all DTCs, turn the ignition off for 15 seconds. Repeat any engine operating conditions that were noted in the freeze frame data and monitor the misfire counter and bar graph. Finally, review the captured information using the scan tool. If there are no more undiagnosed DTCs, the procedure is complete.
Remember, the CKP signal must be accurately read by the PCM to avoid misfire. It's important that you understand how the on-vehicle diagnostic test sets the DTC and what it means when a DTC doesn't set. Misfire can be caused by so many conditions that you need to study the available freeze frame data to understand the exact vehicle operating conditions that cause the diagnostic to fail. And to avoid comebacks, you need to follow the service information diagnostics to the letter. Now let's take a look at some engine performance issues that relate to the evaporative emission system. The evaporative emission, or EVAP system, has been around for years and is designed to capture and store gasoline vapors and then supply them for combustion during certain engine operation conditions. As we all know, an EVAP fault can impact drivability and be difficult to diagnose. Enhanced EVAP systems were introduced with OBD2. Along with the traditional EVAP system components, such as the canister, purge solenoid, and lines, enhanced EVAP systems also have a fresh air vent solenoid, which draws fresh air into the system and helps push vapors through the canister when the PCM opens the purge valve. There is also a fuel tank pressure sensor, which measures the difference between the atmospheric and fuel tank pressure. And finally, most enhanced EVAP systems have a service port with a green cap on the purge line for diagnostic testing. We'll talk more about this in a few moments. Another emission control enhancement related to OBD2 is onboard refueling vapor recovery, or ORVR. This system operates under the principle that fuel going into the filler tube creates an aspiration effect which draws air into the fill tube. With air flowing into the fill tube, fuel vapors cannot escape to the atmosphere. Instead, they are captured by the vapor canister. As the tank becomes nearly full, the fuel limit vent valve floats up to close off the vapor line to the canister. As pressure builds in the tank, fuel backs up in the fill pipe and shuts off the fuel pump nozzle. Onboard diagnostics are used to ensure that the EVAP system can develop and hold a vacuum, as well as whether individual control components are functioning properly. The diagnostics use a vacuum decay method, where a vacuum is created in the system and the diagnostic checks to see if the vacuum can be maintained. There are several DTCs that are related to the EVAP system. These DTCs cover overall operation and leaks, as well as individual system components. In addition, system vapor generation and capture capacity can be temperature sensitive. Winter-grade fuels on cold days can affect the scan tool service bay test, and hot days can cause high amounts of vaporization in the system. Whether you're diagnosing a DTC or a non-DTC EVAP concern, strategy-based diagnostics is a must. Make sure you understand the failure and follow every step in the diagnostic procedure. For example, typically, the diagnostic will only run if the tank is between 15 and 85% full. If the vehicle in your service bay is full or almost empty, you'll have a difficult time making an accurate diagnosis. Then again, several EVAP DTCs set only after a diagnostic has failed for the second time. If you're diagnosing during the ignition cycle of the first fail, the scan tool status may show not run. So be sure to view the system parameters in this case to determine if the system is functioning. When you're faced with a DTC that must be duplicated, be sure to note all the data in the PCM's freeze frame failure records to recreate the exact conditions that induced the fault. At this point, let's review EVAP Diagnostics on a 2000 Intrigue with a 3.5-liter V6 engine.
As stated previously, the first step in any strategy-based diagnostic procedure is to verify the concern. If the MIL is on, you'll need to perform an onboard diagnostic system check as shown in the service information. But first, make a quick visual inspection. Rule out the possibility of a loose or missing fuel filler cap or service port dust cap. With the vehicle on a hoist, look for misrouted or damaged lines. Also check the canister for charcoal release, which is a sure sign that the canister is bad. Once you've performed the powertrain onboard diagnostic system check, look for any other EVAP system DTCs. Any fuel level sensor DTCs should be serviced first to ensure that the EVAP diagnostics will run. And if you find any EVAP component DTCs, service them first before servicing any system DTCs. Also check for any service bulletins that may offer direct answers to symptomatic concerns as well as overall system-based concerns. Furthermore, the service history may show previous EVAP system repairs, repairs to nearby components, or collision service that may have affected EVAP system performance. Begin scan tool diagnostics by checking for EVAP history codes. Then run the service bay test that is available for most applications. Be sure the vehicle is near room temperature when performing this test. If the engine is too warm, the test will abort. After selecting the EVAP test from the applications menu, turn the ignition off, wait 10 seconds, then turn it back on. Then press Enter on the scan tool to continue the test. Keeping the vehicle in park, start and idle the engine and press Enter again on the scan tool. A message will flash on the scan tool screen that will tell you the test is running. The test results are displayed upon completion. The next test is to check the purge valve. You'll need to record and clear all DTCs to enable the output functions of the scan tool. Remove the purge line from the purge valve solenoid and connect the handheld vacuum pump J23738-A to the vacuum port at the valve. Apply 10 inches mercury vacuum and see if it holds. If not, check for carbon contamination in the valve. If the solenoid doesn't click and the solenoid DTC P0443 is not set, connect a vacuum gauge to the purge valve. With the engine idling, command the purge valve solenoid to 50% at the scan tool. You should get at least 12 inches mercury. If you have good vacuum, check for carbon contamination in the line. If there is no vacuum or weak vacuum, then the vacuum source is suspect. Also, check the purge line from the valve to the canister. Disconnect the line at the canister and apply 5 inches mercury with the handheld pump. If it doesn't hold, you'll need to check the line. If the components and lines check out, you'll need to use the EVAP Pressure Purge Diagnostic Station J41413 to continue your diagnosis. Refer to the manufacturer's instructions to ensure proper use. The J41413 is used to pressurize the EVAP system with nitrogen. The nitrogen cylinder needs to be refilled whenever the tank pressure drops below 100 psi. A 125 cubic foot size tank is recommended for this tool. And this is very important. Never substitute nitrogen with any other type of gas. Begin by zeroing the gauge on the EVAP station and making sure all EVAP components and lines are properly connected. Then connect the station to the EVAP service port. Using the scan tool, command the vent valve on. Again, this will close the valve. Now you'll be using the station to pressurize the system. If it doesn't work the first time, try again. Several attempts may be necessary. With the system pressurized, use the ultrasonic leak detector to find the leak. Be sure to check around the fuel tank, canister, EVAP purge solenoid, EVAP diagnostic switches, and pressure control valve, plus all system lines. You may need to lower the fuel tank slightly to check the lines above it.
If you personally don't care for the ultrasonic detector, you can use the Snoop leak detection solution. Ordering information is in the reference book for this know-how release. Be sure to use Snoop, as other ammonia-based soap solutions can damage components.
After finding and repairing the leak, check your work by running the onboard diagnostic again. Use the scan tool to verify that the test has been run and passed. Remember, you might want to do this over 2 ignition cycles to be sure. Also, be sure no new DTCs have been set.
When performing EVAP diagnostics, you need to understand the onboard diagnostic tests that set the various EVAP DTCs. Duplicating the conditions is essential to successful diagnostics in your service bay. As with any diagnostic procedure, leak checking with the EVAP diagnostic station tool requires careful work. The EVAP system runs with very low vacuum levels, and leaks may not be obvious, so it's important to pay close attention. Before we close, we want to take a moment to talk about the Catera. The 1999 and 2000 Catera anti-theft or immobilizer learn procedures for ECM replacement are the subject of much confusion. Be aware that the procedure varied from previous model years, which caused the scan tool menus to also change. It's important that you have the most current software version available in the Tech 2 and the TechLine terminal and follow the instructions on the TechLine screen and scan tool when programming either unit. Engineering is reviewing even more capabilities regarding Catera programming. And finally, there's a new rod bearing measurement tool, number J43690, that is available to set bearing clearances. This tool eliminates the old trial and error plastigauge method, making service faster and more accurate. Some applications require the use of an adapter that comes with the tool and attaches to the dial indicator. In these cases, be sure to use the lock ring to secure the adapter. And here's another tip. When you first receive the tool, the gooseneck may be adjusted out all the way. If so, make a coarse adjustment like this before you make the fine adjustment. This will secure the gooseneck in the desired position. We've covered a lot of ground today, but keep this in mind. All of the styling and convenience features in the world won't mean a thing if your customer experiences chronic engine performance concerns. Your ability to diagnose conditions and make repairs is essential to maintaining your customer's enthusiasm for their GM vehicle. In other words, you can help your present customers remain future customers. That wraps up this GM service know-how on engine performance issues. Be sure to consult the booklet that accompanies this video. It contains additional vital information that will help you keep your customers' vehicles running as they should. And don't forget to take the test in the booklet to receive your training certificate. The instructions for taking the test are coming up next. For GM Service Operations, I'm Linda Quiros.
All testing for the GM Service Know-How program is now accomplished through the GM Service Technical College website. The interactive voice response system is no longer active. To receive credit for this course, please access the GM Service Technical College website at www.gmstc.com and select Training Management from the menu. This will take you to the Training Management System. A valid username and password are required for this portion of the site. Once you have been granted access to the system, select the Tests option. From here, you will be presented a list of available tests. Select the test you wish to take and follow the prompts. This testing procedure provides immediate results at the completion of the test and is linked to the GM Service Technical College Training Management System. Course completion certificates are mailed within 3 to 4 weeks. Your opinions and suggestions are welcome as a way to improve future GM Service Know-How releases. A survey form is available at the end of the course test.